Yes, sir.
So
So we
we were
did a question based on points.
discussing NEET questions, right? I
Yes,
think.
sir.
Okay, okay. So Samara, you're preparing for JEE or NEET?
Needs, sir.
NEET. And Krishna, you're for JEE, right?
Yes, sir.
You were absent in the last class. I remember you were present.
No, sir, I was absent last class.
So till now, is there any doubt what we have discussed? Any kind of concept you want to discuss, or have you not understood something kind of
Sir, actually, I think I was present, sir. Yes, sir, I was present.
that is why I'm telling you. I have asked some question and like
Yes, sir.
so we were discussing a thing, topic. We were
Yes, sir. We
discussing
discussed the 24th question.
24. So I think we have already we were discussing 24. This one.
Yes, sir. We finished it.
Other questions are easy. I think if you see question number 25, that is verbally all we all can solve. We know that torque on a dipole placed in electric field is P cross E, right? We all know that.
Yes, sir.
So for 25, all of you see question number 25. It's very easy question. Torque acting on a dipole placed in electric field. We all know that is torque is P cross E, right? And then now we see question number 26. This type of question is also asking JEE. So all of you go through question number 26. Have all of you gone through question number 26? It says a semicircular arc of radius A is charged uniformly. I'm audible to everyone. Hanifa, Krishna,
Yes, sir.
Samaira.
Yes, sir.
Okay.
Yes, sir.
So a circular arc of radius A is charged uniformly, and the charge per unit length is lambda. The electric field at the center of this arc is. So we have to find the electric field at the center of the arc. So how to solve this question? Anyone can give some idea? How to find electric field into a arc? Generally, someone is saying, Hanifa is saying option A. How option A, Hanifa?
Because like the voltage and the product of current and resistance.
Sorry, your voice is breaking. Can you say again? Can you say it again? Anyone else? So let us see. I will give you two methods to solve such kind of questions. First is very easy. You know, sometimes you have to use option elimination method, which I will teach you throughout the lectures and throughout the classes. That is very important for JEE main and NEET exam. So here, first I will go through the option elimination method. So see, if we see in the question, charge per unit length of the semicircular arc is lambda. So we know that the unit of electric field, if we see, what is the unit of electric field? We have to find electric field at the center. First, I will explain in question. There is a semicircular arc of radius A. What it means? Suppose we have an arc, this kind of thing, structure is there, and its charge per unit length is lambda. In the question, it says that there is a semicircular arc and its radius is A. Its radius is A and charge per unit length is lambda. Then the electric field at the center of it. So we have to find electric field at the center of the arc. Suppose the center is 4. So we know that what is electric field? Electric field is actually, if you say for anything like I wanted to know the unit of it. If you see the unit of electric field is, what is unit? That is, we know that electric field of a point charge
Newton
is,
per coulomb.
that is also Newton per coulomb, force per unit charge. So and Newton per coulomb or kind of thing, I can also say we know that electric field due to a point charge is 1 by 4 pi epsilon naught q by r square kind of thing, right? Electric field due to point charge. So if I separate unit of this one, this has some unit, I leave the unit of this. So unit of this is coulomb per meter square should be there, right? Coulomb per meter square should be there. Apart from this, this term should be there, and apart from that, this term, there should be a term containing coulomb per meter square. So using this, we will do the option elimination. If you see option B, first I will go through option B. What is it? It is lambda by 2 pi epsilon naught a square. If I go through option B, electric field is given as 1 by 2 pi epsilon naught lambda by a square. 1 by 2 pi epsilon naught lambda by a square. So this term has same unit as 1 by 4 pi epsilon naught. So this term is okay. But if you see this term, what is the unit of this lambda? What is the unit of lambda? Anyone can say? Can anyone say what is the unit of lambda?
Coulomb per meter.
Correct, coulomb per meter. And what is the unit of a square?
Meter square.
Meter square, correct. So what is the unit of this term? This term will have a unit of coulomb per meter cube. But we need coulomb per meter square, right? And this term is coulomb per meter cube. It means option B cannot be correct. Getting my point or not?
Yes,
Yes,
sir.
sir.
Now go to again see option D. That is also not possible. See the option D. It also has lambda square by A. If you see option B. So apart from 1 by 2 pi epsilon naught, the term is lambda square by A. It means it will be coulomb square per meter square by meter. It means it will be coulomb square per meter cube. So this is also not possible. Everyone getting my point?
Yes, sir.
Yes, sir.
Then again see option C. If you see option C, which is lambda by 4 pi square epsilon A. So you always remember that in electric field kind of thing, there is always linear term like 2 pi epsilon naught, 4 pi epsilon naught. There is never pi square term. You will not find it. If you see 90% of the result are like that 1 by 4 pi epsilon naught, 1 by 2 pi epsilon naught. So this cannot, or this is also not possible. If you see, generally we don't do it. If you see option A, B, C, A, B, and D, all are having linear term, pi epsilon naught. No one is having pi square, and we never get pi square in the expression of electric field. So C is also not possible. Have everyone got the point?
Yes, sir.
So what is the possibility of the answer? So without solving, we can say that the option is A. I am always teaching the students while solving the question for NEET and JEE. Always keep trick to solve using option elimination and other methods also. And if you see, gradually you will come to know. And if you will see a paper, there is always 4 to 5 questions are such that can be solved by option elimination method. And you cannot generally you cannot apply the option elimination method very easily. You have to have some kind of question. You should have to practice question. Without practice, this will not work. So I will teach you in each and every chapter how to eliminate options. Gradually, you will learn. It's not randomly or at a certain you will learn it. By step you will come to know how to eliminate options. and it will be very useful for NEET and JEE main exam. In every paper, at least 4 or 5 questions are saying that, which are very lengthy to solve, but you can solve directly by using option eliminations method and other methods also that I will give you later on the shortcuts. So here, if you solve this question 26 by normal method, it will take at least 3 to 4 minutes. It will take sufficient time because it requires integration to solve this problem. So rather I will suggest the students to apply that method in this, and easily we can say that the correct answer is A. I will uh, let you know how the answer A comes, but for example purpose you can directly go to option A. Everyone understood what I am saying? What I'm trying to say?
Yes, sir.
So this is now I will give you second method how to come to option A. So everyone got Hanifa, Maimuna, Samaira, all of you understood how we eliminated 3 options?
Yes, sir.
Okay. Now come to general method, how electric fields comes as lambda by 2 pi epsilon naught. So let us see the structure. We have a semicircular structure and we have to find the electric field at the center. So to do that, first we have to find a pointer. Basically, we will do the integration method and at some angle theta. Suppose this angle is theta, and we will consider a small element. For such kind of problems where continuous charge distribution is there, we always have to consider a small element, then find the electric field of the small element, then integrate it. That will be the general method. So here also we have continuous distribution of charge. So for that we will consider a small element. Suppose this angle is d theta. There is a small element at angle theta, and the thickness of this elementary portion is d theta. So first we will find the electric field due to this elementary portion, and then we will integrate it. So what we will do first, we will find the how we will find the electric field due to this elementary portion. We will apply Coulomb's law to find the electric field, or general formula of electric field due to a point charge. So we will consider this element. Consider this element. Suppose we gave the name as AB. Consider this element AB as a point charge. We can assume the element, because the element is very small, so we can assume the element as a point charge. Now, to find the electric field due to a point charge, what we need? We need the formula 1 by 4 pi epsilon naught, that is Q by R square. 1 by 4 pi electric field due to point charge is 1 by 4 pi epsilon naught Q by R square. Q by R square. So we are finding electric field due to this point charge at point O. So if we consider the point charge as a positive, so due to this elementary portion, the electric field will be away from the charge. It means the electric field due to point charge should be along this direction. So let us say that is dE, and we take the charge of this element as dQ, right? And the distance will be A square. So electric field due to this small element dQ, small element of charge dQ, will be 1 by 4 pi epsilon naught dQ by A square. And direction will be in this direction as shown in the diagram. It will be radially away from the charge. So everyone got this expression, how I have written this expression? Anyone having any doubt
Yes,
in
sir.
this expression? Now, what we have to do? We have to find this small charge dq. So that will be 1 by 4 pi epsilon naught 1 by a square. What is the value of dq? We know that charge per unit length of this portion is lambda. So dq will be, what will be the dq? dq should be lambda into dl, length of this portion. Suppose length of this portion is dl. Length of portion AB is dl. Suppose length of this portion AB is dl. Then dq will be lambda dl. Everyone got this? How I have written dq equal to lambda dl?
Yes.
Okay. So now we
So
have
can
to
you
find,
explain again?
we know in the question it is given that charge on the circular arc, charge density of the circular arc is lambda. That is charge per unit length. Lambda is the charge per unit length of the element of the arc. Means arc is having charge which is having linear charge density lambda. Got my point?
Yes, sir.
So to find the charge of an element having length dl, how we will find? We will multiply by lambda. So charge on this element AB will be lambda into dl. Getting my point?
Yes, sir.
And what will be the dl, length of this elementary portion AB? Anyone? What is the length dl? How we will find dl, length of this arc? dl is also a small portion, right? If you see, dl is also a small portion of a circle. If you see like this, dl is like this. This is dl. And this angle is d theta, and this portion is a. So can we find dl? This act as a small arc, very small arc, dl.
Yes, sir.
So what will be the value of dl? You know the formula, right?
So
You have
DL by
seen
A.
the, yeah, you have studied in class 10 also, I think. Angle is arc length upon radius, right? Angle is arc length upon radius. So dl is actually arc length. What will be dl? A into d theta. Got my point?
Yes, sir.
So this is how we can calculate arc length. Angle of a arc is always arc length upon radius. So from that we can calculate lambda is given, dl is a d theta. Everyone understood this? How we calculate dl? Anyone having doubt? Please ask. Hanifa, Maimuna, Samaira, have all of you got how we
Yes,
calculate
sir.
dl?
Yes, sir.
Okay. So I will put dq here. I will put the value of dq. So I will get it as lambda a d theta and 1 by 4 pi epsilon 1. Now, so this is how we calculated B. But we have to find total electric field. So I am missing something here. So can anyone say now what we have to do? We have calculated DE. So should we integrate it to find the electric field, or what we should do now after this? Can anyone suggest me this step? Further step? What we should do now? We have calculated D. that is electric field due to elementary question EB. What should we do now?
Sir, AA gets cancelled and then we integrate.
Which get cancelled?
Sir, A.
AA will cancel, that is true. A will cancel out, right? Yeah, let us see. A will cancel out and then we will get the term but one more thing I think we are missing. We have to think it about it. One more thing we are missing here. Let us integrate. Let us see what happens to the field. So here I am integrating. D is equal to, from that if we get D equal to, let us see what we are getting the result. 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught, we will get lambda d theta by a square, right? We will get lambda d theta by lambda d theta by 4 pi epsilon and naught a, right? A will be cancelled out. So we will get lambda d theta by 4 pi epsilon naught a, right? Now to
Yes, sir.
find the total field E, if we integrate this one, what we are getting, we will get lambda d theta by 4 pi epsilon naught a. So 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught 1 by a will also be out, lambda will be out. So we will get d theta, right? And what will happen? We will get 1 by 4 pi epsilon naught lambda by a. What will be the value of theta? What will be the limit for theta? Do you know do you have some idea when we are using some limits in integration? How we use limits? Here if you see, theta will vary from 0 degree to pi, right? Theta will
Yes, sir.
vary from 0 degree to pi, correct or not?
Yes, sir.
So from that, what we will get, theta will vary from 0 to pi, that is 180 degree. So integration of d theta will be theta. Integration of dx is x. Integration of d theta is theta. Always anything comes in integration, like we have integration dx, its integration is x. And if you are putting something as a limit, suppose you are putting x1 to x2 limit, so its value comes as integration x. And if there are limits there, you just put values like this and put upper limit minus lower. This is how we proceed in integration which contains limits. See, so here we are also using the same formula. Here integration of d theta is theta, and we will put limit like this 0 to pi. So we will get 1 by 4 pi epsilon naught lambda by a into pi minus 0, right? Pi minus 0. So what will be the value? What will be the value we get? We are getting, we will get the value as E will be equal to 1 by 4 pi epsilon naught lambda by a into lambda by a into pi. Pi minus 0 will be pi. So it will come as lambda by 4 epsilon naught. Is it dimensionally correct? Dimensionally it is correct. But if you see the option, it was 2 pi epsilon naught a, right? So I
Yes,
was
sir.
saying we are something missing. You have to find what we are missing. Then I will correct the result. Generally, this is the kind of mistakes generally students do while solving such questions, and we end up with a wrong result. So here you have to identify what kind of mistake had been made, what kind of mistake that could be. That we have to find. Anyone? What mistake had been made here? That is why we are getting a wrong result. It seems to be correct. Everything seems to be fine, but something is missing here. I was saying earlier also, but I solved it so that you can know better how to identify the mistakes and what mistakes can be done. Let us see. Here see, generally when we find the electric field, electric field is a vector quantity. It's not a scalar quantity, right? So merely you cannot integrate vector quantities directly. First, you have to find its direction, its resultant value, then you can integrate. Here, if you see the electric field is having some directions, it means it must have some components. It must have some components. If you see this point like this, electric field is like this, I will break it into two components. It can be broken into two components. One is, if you see, this angle is also theta. If this angle is theta, uh, this angle should also be theta, right? That angle is theta. This angle should also be theta. So this electric field D can be broken into two components. One will be D sine theta and another will be D cos theta. Getting my point or not? This electric field will have two components. Since it is a vector quantity, this must be broken into two components. One is D cos theta and another is D sin theta. Have everyone got this point? How I have broken this one into two components?
Yes, sir.
So I will draw this diagram in fresh page so that Let us see. This portion is like we have taken theta, and the electric field due to this element is, this is small element is here, like this is D. So if you see, this angle will also be theta, and if we consider this as x, this as y, so it will have two components. What is this component? D cos theta, and what is this component? D sin. Okay. Similarly, what will happen? So everyone got this point, how I have broken D into two components, D cos theta and D sin theta. Everyone know to break
Yes, sir.
the vector in, to resolve vector into components. Everyone familiar with it? Anifa, have you understood how we have broken D into two components? D cos theta and D sin theta. Mamuna, Samaira.
Yes, sir.
Yes.
So what will happen if you broke it into two components? Now again, suppose I take element here. So in that case, its electric field will be like this. Here it will have D, and it also have, if I took same angle, like I took this angle as theta, then here will be theta. So it will also have two components. One will be here D cos theta, and another will be D sin theta. So D cos theta component are opposite. If you see D cos theta component, which are opposite for two elements. So that's why while considering the net electric field, we have to consider only this component D sin theta. D cos theta component will be cancelled out. Everyone got my point? What I'm trying to say. So we cannot integrate D directly. Net electric field will be along Y direction, and its component is D sin theta. Getting my point?
Yes, sir.
So to find net electric field, what we have to do? We have to put here, we have to take sin theta component. So to net electric field will be along Y direction. So to find net electric field, we have to take DE sin theta. Getting my point? Not integrate directly DE, we have to take D sin theta. Everyone got this? How I found D sin theta? How we are integrating D
Yes,
sin
sir.
theta? No? Okay. Now put the value of D. What was D? D was, if you see D was lambda d theta upon 4 pi epsilon. D was lambda d theta upon 4 pi epsilon naught. D was lambda d theta upon 4 pi epsilon naught. Lambda d theta upon 4 pi epsilon naught and sin theta. Now we have to integrate to find the net electric field. So now to net find, we will find Ey by integrating this one. So it will be lambda by 4 pi epsilon naught A sin theta d theta. Now integrate this one. We will integrate from where theta will be vary. Theta will vary from 0 to pi, right? So theta will vary from 0 to pi. So the net electric field will be like this, lambda by 4 pi epsilon naught. What is the integration of sine theta? Anyone can say?
Cos theta.
What is the integration of sine theta?
Cos theta.
Cos theta, right? It's minus cos theta, right? Integration of sine theta is minus cos. You may have studied basic mathematics, right? Or you're in class 12, so later on you will come to know in detail, to come to know about integration in detail. So from here you will get minus will taken as outside, so lambda by 4 pi epsilon naught a and cos theta 0 to pi. So net electric field will be like this. Ey, we can say electric field is along y, that's why we are putting Ey, lambda by 4 pi epsilon naught a, and we will put value of limits cos pi minus cos 0 t. So we will get that minus is outside there, so minus lambda by 4 pi epsilon naught a. What is the value of cos pi? What is the value of cos 180 degree? Anyone? What is the value of cos pi? You don't know cos of 180 degree. Anyone? Hanifa? What is the value of cos
Sir,
180?
-1 I think.
Yes, minus 1. Cos 180 is minus 1. And what is the value of cos 0?
180.
1.
Cos 0 is 1. So it will come as minus minus plus. It will come 2 lambda upon 4 pi epsilon naught. 4 pi epsilon naught a. So what is the value of electric field we got? E is equal to 2 and 4 will be cancel out. We will get lambda by 2 pi epsilon naught a. Now match the option A. We are getting the correct result, right? 1 by 2 pi epsilon
Yes.
naught lambda. So see how lengthy it is. But this method that we should know, because this is the general method. This will be applied in any case of finding electric field due to continuous distribution of charge. So have everyone understood this? How we got lambda by 2 pi epsilon naught t?
Yes.
Question we have already solved earlier by short trick method, but I have explained you in detail how to solve such a question. So let me go briefly once again what is the general method to solve such a question. So what we have to do is, first we have to consider a small element. Our first step will be to consider a small element at angle theta. Then we have to apply the same formula of electric field into a point charge. What is the electric point of a point charge? 1 by 4 pi epsilon naught q by r square. So here same method will be applied. 1 by 4 pi epsilon naught dq by a square. Now we don't know dq. What is the value of dq? So for that, what we did, we applied this concept, arc length, arc angle theta is equal to arc length upon radius. So from that we have calculated the dq. What was dq? Dq was lambda dl. And what is dl? Dl is a d theta. So from that we put the value of dq as lambda a d theta. Everyone got this till now?
Yes.
I am briefing it again. Then what we did, now We can now we have found D. Now we should not integrate it directly. In this way, we will get the wrong result. So for that, what we have to do, since electric field is having direction, if two displacements are acting in some direction, you cannot add them merely. A vector cannot be added merely. We have to find directions. So for that, we have broken this electric field into two components. One is along y direction, which was d sine theta, and one was along d cos theta. Now, d cos theta will be cancelled out when we consider two symmetric elements. Like if we take one element here and one element here, just we have assumed. So d cos theta component will be in opposite directions. So to find the net electric field, we have to consider the sine theta component only. So for that purpose, we have taken d sine theta. Now after this, there is no physics, only mathematics is there. You have to put the value of d, which we have calculated earlier. Now by putting the value of d, you will get the term sine theta d theta. Now integrate it and put the value of theta carefully. Here to cover the whole element, theta should vary from, to consider the whole half ring, theta should vary from 0 to pi. If the ring had been quarter, what should be the limit of theta? If the ring had been quarter, if the ring is quarter, what will be the limit of theta?
Is 0
Anyone?
to pi by 2.
Correct. When this ring is quarter 1, the limit of theta will be 0 to pi by 2. Correct. So here the ring is half, so it's 0 to pi. If ring is full, then the limit of theta will be 0 to 2 pi. Got my point? If ring is full, then the limit will be 0 to 2 pi. So here we have put the limit as 0 to pi, and we have done the integration of sine theta is minus cos theta, then we got it. So physics already ended here. If you see, it was not much difficult. Just we have to consider element, find the component of electric field, then just to integrate. So everyone got this question? This will be very useful since we will get such type of continuous distribution of charges, uh, especially for JEE. Such type of questions are very important. In NEET, rarely such type of integration kind of things are asked, but we should know the concept. It is very useful. Actually, if you see, this is the NEET question. Nowadays, such kind of questions are not much asked in NEET, but for JEE, this is very important for JEE main. Since in JEE main, most of the questions are based on continuous distribution integration kind of thing. So they must understand this. But for NEET students also, for concept point of view, this is very important. It will be helpful to solve some question in short, in short text also. I will explain. So everyone got the concept till now, or we have got this one? Okay. Anyone having doubt, please ask. So based on this, I am giving you two questions. Question number 1, find the electric field due to a quarter ring. Suppose the ring is having charge per unit lambda and radius is small r, then find the electric field at the center O due to this quarter ring. We have to solve it right now. And second question is find the electric field at the center due to full ring. Suppose we have a full ring and charge current length is lambda and its radius is small r. So we have to find the electric field at the center. So all of you first solve question number 1, then question number 2, and give. Uh, I will ask each and everyone what's your answer. I will take answer from each of you. So everyone solve this question number 1 and 2.
So can this answer be done with the help of Gauss law?
No, we cannot apply here Gauss law.
Okay.
I will explain you why. I will explain you why. Anyone got the answer? Quick. I will give you some options also. Do you need options? Do you need options?
No need, sir.
So, Maimuna, what is your answer? Are you doing it or have you solved it? Maimuna, can you hear? Hanifa?
So I'm getting 90 for the first one.
How much?
90.
90. No, I am asking the electric field at the center O. Have you got the question? What I am asking?
Oh, okay, sir.
I am not asking angle. I am asking the value of electric field at the center O due to this quarter charge. Samaira?
Sir, I'm finding.
Okay. Krishna, have you got?
No, sir. Solving.
you are NEET and JEE main students, so you should not take this much of time, especially for NEET students, they should be too quick. JEE students can have some time since they are having 30. How much questions are there? I think 30, no? 30 questions, 3 hours. But they are in total, if you see 90 questions, right? JEE also. Mathematics, physics, chemistry. C. Anyone got answer? Should I solve it? See, we have calculated the electric field due to semicircular wire at the center, right? At this point out. What was the electric field which we have calculated? Electric field. What was the value of electric field at the center? What is the electric field we have calculated just now?
Sir, I got the answer for quarters, sir. I think it's pi by 4 pi epsilon naught a.
How much can you say again?
So pi by, I mean, yeah,
Lambda.
lambda by 4 pi epsilon naught a. Yeah.
Okay. I think you are correct. Lambda by 4 pi epsilon naught is the correct answer. How you got it?
Sir, in place of pi, I think we have to just do pi by 2, right? Cos pi by 2 to 0.
0 to pi by 2 you have taken limit, right?
Yes, sir. Yes, sir. Yes, sir.
Yes, yes. And what is the in second case? Have you got any? Okay, so this value lambda by 4 pi epsilon naught is correct answer. Anyone else got? So see, the first method is like this. We can do this, but if you see just over your diagram, the integration is there. So here what you have to do? You just have to change the value of limit.
So for full circular ring, I think it's 0, right?
Yes, it should be 0. Should be 0. So the integration is above your diagram. So for quarter circle means for up to this portion only, the theta will vary from 0 to pi by 2. 0 to pi by 2. Getting my point or no? So in this integration, what will happen? You will get the integration as 0 by pi by 2 sine theta d. I am not doing the whole expression. I am just calculating the integration. This is the main part, right? So sine theta will be minus cos theta, and the limit will be 0 to pi by 2. So you will get this result as 1. You will get this result as 1. And if you will put that value, you will get, earlier you were getting 2. In the numerator, you were getting 2, right? Now you are getting 1. So net will be 1 by 4 pi epsilon. So if you see, I will like electric field we have calculated like this. It was 1 by 4 pi epsilon naught. Lambda by 4 pi epsilon naught A, it was like this, sin theta dt. So for the quarter circle, like this, theta will vary from 0 to pi by. So we'll get the electric field as 1 by 4 pi epsilon naught lambda by A. Sin theta will be cos theta minus cos theta, and theta will vary from 0 to pi by. So from here, what will be value? 1 by 4 pi epsilon naught lambda by A minus, I will take minus outside also. So I will take minus outside. The source will be cos pi by 2 minus cos 0. So it will be, so this quantity will be equal to cos 0 is, cos pi by 2 is 0 minus 1. So it will come as lambda by 4 pi. Everyone got this? How we have calculated lambda by 4 pi epsilon naught A?
Yes, sir.
Now, now, I will give you one more short trick in this. What short trick you can do? No need to do integration. Just what you have to do, you have calculated electric field of this one. What is that? 1 by 2 pi epsilon naught lambda by A, right? Now you have half part of this. Now what you have? Half part of this. Only quarter is there. So what will happen? Charge is half. So electric field become half. Correct or right or wrong? Now you have
Yes.
only half part, right? Half part is removed. So electric field will be, suppose this value is E. So now what will be E dash? E dash will be E by 2. No need, because this is a symmetric case. So directly you can half, and lambda electric field will be lambda by 4 pi. Everyone got this or not?
Yes, sir.
Yes.
So no need to do calculation, directly you can calculate. You should have given answer in a fraction of in a second. Like
So then how can we calculate for the full circular ring?
full ring. Yeah, that is also I will explain you. Now coming for the full ring. Full ring is like this. E is equal to again lambda by 4 pi epsilon naught. Now if the ring is full, so here theta will vary from like 1 by, I will do it separate. Should I do? I will do here lambda by 4 pi epsilon naught A. Now sin theta d theta. Now what is the range of theta? It will be 0 to 2 pi, right? For full range, it will be 0 to 2 pi or not? Are
Yes,
you
sir.
getting my point? So it will be lambda by 4 pi epsilon naught A. And what is the integration of sin theta? Cos 0 to 2 pi. Now this term will be equal to 0. You know, if you find the value of this one, cos theta 0 to 2 pi, so it will come as cos 2 pi minus cos 0. So what is the cos 2 pi? 1. And what is the cos 0? Also 1. So it will be 0. So this term is 0. That is why electric field at the center is 0. Getting my point?
Yes, sir.
Yes.
So but you said without integrating, right?
Yeah, without also I will explain you. First I have explained you with integration. So with integration everything can be solved. Without also I will explain you short trick for this also. Without any calculation you can say that electric field is 0. I am going to explain that. So short trick for that. Save your time, save calculation. So what you will do here, you see here we have a symmetric case, right? So electric field at the center is equal from all directions. If you see from this and from this direction, if you see from this and from this direction, from this, so from each and every direction there is equal and opposite electric field. Getting me or not? So what
Yes,
will
sir.
be the resultant electric field? Should be zero. If you see from all sides electric field are coming and every pair is having opposite pair. So what will be net electric field? It should be zero. So without any calculation, you can say that at the center of the ring, electric field should be zero if it is full ring. In any case, you will find, you may have, you have studied electric field if a shell at the center is zero. You have studied or not? If a shell
Yes, sir.
or to the solid sphere also electric field at the center. So in each and every case, if the distribution of charge is uniform, not in non-uniform. If distribution of charge is uniform, electric field at the center is always zero. All of you got my point?
Yes, sir.
Anyone having doubt? Hanifa, Maimuna, Samaira?
No,
No,
sir.
sir.
Okay. So this is how we have to solve such kind of question. Now your question was why not we can use Gauss law. I told you we cannot apply Gauss law. So when you have studied Gauss law, you may have studied one statement that Gauss law is always applied for symmetric cases. Gauss law is always applied for symmetric cases. Here we don't have symmetric cases, right? If you see the ring is half, so how you will consider Gaussian surface? We cannot consider here Gaussian surface, right? It is asymmetric. So such kind of and if you have like two-dimensional structure and which is also half, so it is not symmetric. Symmetric case means if a single wire is of infinite length, or if we have a solid sphere, those kind of things are symmetric cases. But here we have a finite charge distribution, two-dimensional charge distribution. It cannot be symmetric. Or a quarter ring, how it is symmetric? It is not symmetric, right? So we cannot apply. Getting my point? How we'll consider Gaussian surface? Gaussian surface should be such that at each and every point electric field should be same. And when we are applying Gauss law, we have to consider a Gaussian surface. We should have electric field same at each and every point. Here we have two-dimensional structure. If you see here, in Gauss law, we must have a three-dimensional thing. Then we will, then we will get area. Here we have length only. You see, here we have only length, so we cannot get area on. So from any point of view, we cannot apply Gauss. Getting my point?
Yes, sir.
So that is why we should not apply Gauss. So the question was seen to be so first, for such question, it will take your body time to going to get integrate. So in most of the cases, for such cases, you must remember the result directly. That is very important. You should by heart today onward. You should by heart that electric field due to a circular arc, semicircular arc at the center is 1 by 2 pi epsilon naught lambda by a. I am telling you, it will be very useful. It will be very helpful. Otherwise, every time you cannot get such option, right? In this question, you got that option that you can eliminate. but every time, suppose you have got 4 pi epsilon naught a, right? In place of 4 pi square, suppose the option has been given like 4 pi epsilon naught a. So in that case, how you will apply shortening? So generally they give such kind of options. They frame the question with such kind of options so that we can eliminate. Since they also know, the examinee or paper setter also know that we don't have that much of time to integrate. So they test our, presence of, you know, test our presence of mind or something. So such questions have been framed so that we can do option elimination. But for JEE purpose, you have to do integration also. In NEET, there will be some option which you can. Getting my point?
Yes, sir.
Okay. Now moving to the next question. 20. So everyone say what is the electric field due to a semicircular arc at the center? Say, all of you say same time, what will be the value of electric field? Repeat yourself. Formula should be keep repeating by yourself to by heart the question, or you do some kind of sheet kind of thing. You, or when you do a class, always note some important formula and have a formula sheet with yourself so that you can paste it in your room or some where you can window or room or on your desk so that easily you can memorize the formula. So for electric field due to semicircular area, it's suggested that you should remember. Now moving to question, next question, that is question number 27. So a hollow insulated conducting sphere, the question 27 says a hollow insulating conducting sphere is given a positive charge of 10 microcoulomb. 10 microcoulomb. List of what will be the electric field at the center of the sphere if its radius is 2 meters. So all of you go through question number 27, and I think all of you can answer it easily. Answer it, question number 27. Have everyone got the question? Okay, one answer I got from Nipa. She's saying A, Krishna is saying A. A is the correct answer, right? Electric field, very easy question. Electric field at the center, always zero, whatever be the radius. So no need to solve this question number 27. The answer is A. Electric field at the center of a shell is always zero. Electric field at the center of a conducting charge sphere is always zero, whatever be the radius. Moving to question, next question number 28. Go through question number 28, everyone. Point Q lies on the perpendicular bisector of an electric dipole. A point Q lies on the perpendicular bisector of an electric dipole of dipole moment P. If the distance of Q from the dipole is R, if the distance of Q from the dipole is R much larger than the size of the dipole, then electric field at Q is proportional to. So basically we have to find electric field at equatorial position or perpendicular bisector. Very easy question. So all of you should answer this question number 28. Very easy. I want answer from each of you. We have to find electric field on the perpendicular bisector of a dipole. That is nothing more than that. So Krishna says the answer is D. Anyone else? Let us see. We have a dipole. We have a dipole. And this is the equatorial position. There is a point P here. Suppose this distance is R and dipole is like this, minus Q plus. So we know that electric field at axial point of a dipole. What is it? Electric field at axial point.
So K2P by R cube.
Yes, K2P by RQ. Electric field at axial point. And what is the electric field at equatorial point?
KP by R cube.
KP by RQ. So you can see the electric field is proportional to P and inversely proportional to 1 by R. This is the question. This is your answer. So only you have to remember the formula. Electric field is 1 by 4 pi epsilon naught or K into 2P by RQ or K into P by. All of us know this formula. Okay. Have everyone understood? Anifa, Maimuna, are you getting?
Yes, sir.
Yes,
It's
sir.
very easy. Only we have to apply the formula to see which one is the correct option. D is the correct answer. Proportional to P and inversely proportional to R. So correct option is D. Now move to question 29. Solve question number 29. Question number, all of you go through question number 29, which says from a point charge, there is a fixed point A. At A, there is an electric field of 500 volt per meter and potential difference of 3000 volt. Let's stop. Distance between point charge A will be distance between point charge and A will be. So first I will explain you the question, what it is saying. says that from a point chart there is a fixed point A. Suppose I have a point chart. I have this point chart, and from this I have a point A. Suppose I have a point A here. Okay, and this charge is Q. So change from a point charge, there is a fixed point A. At A, there is an electric field of 500 volts. So question says that here the value of electric field EA is 500 volt per meter. The value of electric field is this. Okay. And potential difference of 3000. And it is also saying that suppose this is point O, the potential difference, the potential difference between A and O. Suppose potential difference this VO minus VA. In the question, it is given as 3000. The potential difference between point A, point O and A is given as 3000 volt. Okay, electric field is given, potential is given. Find the distance of point charge. So we have to find, suppose the distance of point charge from O to A is R. So we have to find this distance. Have everyone understood the question? What it is saying and what we have to find? Electric field at point is A is given. We have to find distance. Potential is. So now, when you are solving such questions, first you have to see what the things has been given and what are the things which we have to find out. So here you see electric field has been given, potential has been given, and distance we have to find out. So can anyone suggest me what kind of formula should I apply which contains both all the three, potential, electric field and distance?
So E is equal to V by R.
Very good. E is equal to delta V by R or dV by R or delta V by delta. You know, we have given the electric field, we have given the potential difference, and we have to find distance. So for that purpose, we can apply this formula. E is equal to delta V by R. Electric field is given 500. Potential difference is given 3000. R you have to find. From here you can find 300 by 500. 6 meters. Option A is correct. So it is R is 3000 by, it's 3000 by 5. 6. Have everyone got this? How we have calculated 6 meter? So only
Yes,
the
sir.
question, it's very easy question. It only takes time to read the question. You can solve the question in fractions. So you have to see what kind of formula you have to apply. So I think everyone aware of this one. E is equal to change in potential by. Last question, I am going question number 30, which is also very easy question. So 2 or 3 questions are remaining, then we will finish this topic. So go through question number, then in next class we will do JEE questions. So very quickly to question number 30 and 31, very easy, directly you can answer. Go to question number 30. Intensity of an electric field depend on the distance R due to dipole. We know that electric field due to dipole. Same question number 28. We know that electric field due to dipole is inversely proportional to R cube. If you see here, question number 28. Question number 28. Same thing was there, right? Electric field due to dipole. We have seen that it is proportional to R cube. So electric field due to a dipole is always proportional to RQ. So the correct option is C. Got my point?
Yes, sir.
Now see question number 31. The formation of a dipole is due to two equal and similar charges placed at very short distance. We all know that dipole is formed by placing two charges at very short distance. And again, last question. This two question I will give you assignment. So all of you got your assignments? It is in your portal. You can download from that also. I will give you question 32 and 33 in assignment. And in next class, we will do JEE questions. So have all of you got your assignments? In previous class also I have given some assignments. Have anyone of you got it? You have to go to your portal. You have to download it from your portal. Have anyone got your assignment? Hanifa, Krishna, Mamuna?
No, sir, it was not there.
No one got assignment?
No, sir.
You have to download it from your portal. Okay. From there you can get your assignments. In next class we will do some JEE question based on same topics, JEE main questions. Then we will do the last topic. Then we can move to the next chapter. I think this one having two more topics. Topic 3 and topic 3 will be last topic. So then we can move. We will discuss in next class. We will do topic 3 and some JEE questions.